This is your Unit 3 review, Part 1. So, which sequence has a common difference of negative 1.5? Now, we're still in the multiple choice section here, and that's most of the test is multiple choice. Now, the very back is going to be that graph and maybe a few word problems thrown in. But right here, we're still in the multiple choice section. It says, which sequence has a common difference of negative 1.5? This needs to set off an alarm in your head that we're dealing with an arithmetic sequence. Okay? An arithmetic sequence is what we're dealing with. So that means every step of the way, we need to be adding negative 1.5 to go from one term to the next. So I would just test a few of these out, okay? So maybe this calculator a little bit smaller. So I think it's smaller left and right. So my first sequence is negative 1.5. And I'm going to add to it our common difference, negative 1.5. And we're hoping to get the second term in this sequence. We clearly do not. We got negative 3. This first sequence says it should be negative 1.25. They do not agree. This one is out. Now we do our second sequence. I notice it's still the same thing. Negative 1.5 plus our common difference gives me negative 3. So it works for the second one, but let's test a couple more points on it. Add to that answer, negative 1.5. We should get the third term in the sequence. Uh-oh, these disagree. This says negative 4.5. This says negative 6. That one is out. Now we're on to option C, and it has a completely different first term. So we're starting over from scratch. 2 plus negative 1.5. Again, adding negative 1.5 is the same as subtracting. But it said the common difference was negative 1.5, so that's what I'm going with. We get positive 0.5. That's exactly what we should get. Let's test it again, because remember, B tried to fool us a little bit. Plus negative 1.5. We get negative 1, negative 2.5, and negative 4. Everything on C worked out. Every step of the way, it was subtracting 1.5, or as we like to say, adding negative 1.5. Number 2 is really tricky, and I saw a lot of people today. Not many people ask any questions on it, okay? But by the end of the day, really with my last class, I realized, oh gosh, this problem is tricking people, all right? I thought it was going to trick people because it was a word problem. Turns out it was tricking people because they were having a tough time looking at the explicit formula for a geometric situation, okay? Clearly here, we're timesing by 4 every step of the way. So our common ratio was 4. And our first term was 1. Well, I have to go up and I have to build an explicit geometric formula for that. There it is right there, playing the matching game. Okay? So I need a sub 1 times r raised to the n minus 1 power. That is how I find any term in a geometric. Well, my a sub 1 was 1 times r raised to the n minus 1 power. And you look up here and you say, Mr. L, there's none of those. And people were panicking. They're like, oh, maybe I've just got them backwards. No, you don't have them backwards. You have them correct. But if we multiply anything by 1, oh, I'm sorry, I wrote r there. If we multiply anything by 1, we get just that thing. So this simplifies to 4 raised to the n minus 1 power. Tricky stuff. Number 3, what is the 19th term of the arithmetic sequence defined by the formula given? Plug and chug. All right? You could go through and say, okay, first term is this, I can do it all the time. But if they give us n, and they want to know the 19th term, we just plug it in. So that would be a sub 19 equals negative 2 plus 2/3. 19 minus 1. I'm not going to do that by hand. No way. Put it in the calculator. Clear out everything. Get a blank space. Get negative 2 plus alpha y equals enter. 2/3. Arrow over to get out of that fraction. Parenthesis 19 minus 1. Close it off. Double check. Looks good. 10. So I look up here, open, cross my fingers. 10. Number 4, very similar to number 1. So that one was arithmetic, whereas this one has a common ratio, which means we're dealing with a geometric sequence. We're multiplying every step of the way. Now, this one I do have a little bit of a cheat code for. Okay? I notice that this is a negative, and I know that if I multiply by negatives over and over, it causes an oscillating sign, which means I can actually get rid of A and I can get rid of D, because B and C are the ones that keep flipping signs on me. Now, if you don't see that, that's fine. You can carry through with the problem just like we did number 1, and that's how I'm going to do it from here. I'm just going to start with B. I use some test-taking strategies, okay? I'm going to take the first term in B and test it. Clear it out. 30 times my common ratio of negative 1/2. You can do 0.5 as well, okay? And I press enter. And I get negative 15. But we learned on number 1, test a few points in a row. So I'm going to multiply that by negative 1/2. I do this answer thing by just pressing the multiply button, by not actually clicking any other buttons and just pressing multiply, okay? Press enter, and I get 15 halves, and I look up there and I say, wait, hang on, that's not what it is. These are all in decimals. Well, let's convert it. Math down over to decimals. 7.5, so it's working so far. Now, if I multiply again by negative 1/2, it stayed in decimal form. Calculator's kind of smart and realized, oh, it must want decimal form for this. Negative 375, press it again, 1.875, we're all squared away, the answer is B. If you were in class today, you heard number 5 already talked about. We look here, we say, okay, it's going up at a consistent pace, it's a linear function, which is also represented by arithmetic sequences. So when I'm talking about explicit formulas, I know exactly where to look on the formula sheet, play the matching game, explicit formula, arithmetic sequences. The important pieces here are my a sub 1 and my common difference. Now when you look, you notice that my common difference, instead of being written here, is written there. That's perfectly fine. It multiplies through the same either way. So let's look at our graph. My first term, okay, a sub 1, looks like it's about at 1. It's not at 0, it's not halfway, it's about at 1. So let's go through and get rid of everything that doesn't have their first term being a 1. Well, the only one to get rid of is option A, it was negative 1. From there, I want to talk about the difference between my first term and my second, my common difference, okay? It looks like it goes up to term 2 to about 5. Well, from 1 to 5 means I added 4. So I need a common difference of positive 4. The only option that has that is option B with positive 4. This one's negative 4, this one's positive 2. It would have less slope. That's how we equate arithmetic sequences to linear functions. The common difference is just the slope. I go one term over, I go up or down in some cases, a certain amount every step. Number 6, very similar problem, just wanted you to see it both directions. We're going to talk about the first term, which looks like it's about 80, but I'm using test-taking strategies. I see some 81s floating around, so I think a sub 1 is probably 81. And then I go down to something about between 25 and 30, somewhere in the middle there, okay? And so I start thinking, okay, let's take a step back. This was an exponential, which means it's a geometric and it's explicit. So I'm on the formula sheet again. Geometric explicit looks like that. Meaning my first term comes out front and my ratio is raised to the n minus 1 power. Well, we can eliminate a couple options just with that first term. That one doesn't have a first term listed, so it would be 1. Clearly, my first term is not 1. This one says my first term is 3. That'd be about right here. There's no dot there. These, we were right, it was 81. So now we just have to decide which ratio is correct. So I try the first one. I multiply 81 by the common ratio listed of 1/3.